continents separated by vast expanses of water. This is the familiar image of our planet that we have all shared since childhood. But the Earth has not always looked like this. Over the past 4.6 billion years, our planet has gone through many geological eras. During some of these eras, almost the entire surface was covered with ice, while in other periods, on the contrary, the polar caps melted completely. In the distant past, the continents were not arranged as they are today. Land blocks moved relative to each other, resulting in movement, collision of continents, and the emergence of supercontinents that united almost all of the land masses. About 335 million years ago, there was only one supercontinent, consisting of a large part of the Earth's surface. This continent was called Pangaea, which means the whole Earth in Greek, or all the lands in Greek. Later, about 200 million years ago, this huge landmass began to fracture through the movement of tectonic plates and separate into the continents as we know them today. To think of all the continents coming together like a puzzle is incredible. It's also incredible that earthquakes and plate tectonics could have pushed so much land together to create the world we know today. Life at the time of Pangaea was different than it is today. The climate was warmer and drier. The life of animals and plants was completely different. Most animals suffered a mass extinction. Amphibians tried to adapt to the new conditions in different ways. Some increased their size, or on the contrary decreased it. Others acquired denser, shell-like coverings to better retain valuable moisture for the body. Unusual animals have appeared. As for the flora, ferns, lycopods, and horsetails have almost disappeared. But plants more resistant to drought, such as conifers, have spread. Pangaea then looked like a mystical world where the Earth seemed to have existed forever, and where animals and plants lived in places we could not even imagine. Dear traveler, good morning. Today we will travel through time to the time of the last supercontinent the Earth has known. Before leaving to explore a unique and mysterious world, think of liking the video and subscribing to the channel to not miss anything. Thank you, and have a nice trip. The word Pangaea comes from the Greek words pan, meaning all, and gaea, meaning earth, which means all the lands. This name perfectly refers to the supercontinent, because in the past Pangaea was only one land, since all the lands were then gathered in one place. A supercontinent is a continent composed of most or all of the Earth's landmass. The most recent supercontinent to include all of Earth's major landmasses, and arguably the most famous, was Pangaea. Supercontinents have sporadically joined and broken up over the course of Earth's geologic history. Recall that the geologic history of the Earth is a sequence of events in the development of the Earth as a planet. These events include the formation of rocks, the emergence and destruction of landforms, the rise and fall of the seas, ice ages, and the appearance and disappearance of species of living beings. The most modern definition emphasizes that the supercontinent is a geological formation that, with its structure, affects the distribution of heat flows, air masses of the Earth, etc. It is a large structure, but it does not necessarily unite all the continental blocks. In the distant past, all the continents formed a single whole, the supercontinent Pangaea. This huge continent began to form around 335 million years ago, during the Paleozoic period. Many geological, paleontological, paleoclimatic, and geodetic data that exist today can be considered as strong evidence that the continents were once adjacent and then separated from each other. Between them, ocean basins opened up, but they were nevertheless once part of a single planetary structure on a gigantic scale, Pangaea. During the process of formation of Pangaea from older continents, mountain systems appeared in the places of their collision. Some of them still exist today. For example, the Urals or the Appalachians. These early mountains are much older than the relatively young mountain systems such as the Alps in Europe, the Cordillera in North America, the Andes in South America, or the Himalayas in Asia. Due to erosion over millions of years, the Urals and the Appalachians are now low mountains. Most of this supercontinent was concentrated in the southern hemisphere. The only ocean that surrounded it was called Panthalassa. Life during Pangaea was different from today. The climate was warmer, and the fauna and flora were completely different. Pangaea split about 150 to 220 million years ago into two continents. The northern continent of Laurasia then split into Eurasia and North America, while the southern continent of Gondwana then gave rise to Africa, South America, India, Australia, and Antarctica. Supercontinents existed earlier. For example, Rodinia, which disintegrated about 750 million years ago. And according to some predictions, in the future, the continents will reunite into a supercontinent called Pangaea Ultima in about 250 million years, when Africa, America, and Eurasia will collide. Since the 17th century, scientists have been trying to explain the origin of our planet, as well as its characteristic topography. In this context, the famous English physicist Robert Hooke, a zealous rival of Newton, drawing attention to the fact that the remains of marine animals were found far from the sea, concluded that the contours of the seas and lands had changed repeatedly throughout the history of the Earth. But by the beginning of the 20th century, most geographers believed that the ratio of seas to continents had remained unchanged since antiquity. The relief of the planet would have changed only because its entrails gradually cooled and it contracted unevenly. Others thought that mountains were born from the accumulation of sedimentary rocks. Science is grateful to the German meteorologist and astronomer Alfred Wegener for the various justifications of two fundamental geological ideas. First, for the idea of continental drift, and secondly, for the hypothesis that in the distant past of our planet, all the present continents could have formed a single giant supercontinent, Pangaea. According to Wegener, it all started during his stay at the University of Marburg in 1910, when his roommate received the latest edition of the Earth Color Atlas for Christmas. The idea of moving continents first occurred to Wegener when, while studying the world map, he was struck by the similarity of the coastlines on both sides of the Atlantic Ocean. In the fall of 1911, Wegener had become aware of paleontological data on the past land coherence between Brazil and Africa, of which he had known nothing before. This had led him to analyze the results of relevant geological and paleontological studies on this question. After studying these data, he was convinced of the fundamental correctness of his idea. Inspired by his unusual concept, the 31-year-old Wegener dared to present it on January 6, 1912, at the Congress of the German Geological Association in Frankfurt am Main. Wegener explained that the continents had not always been where we saw them on the map. Throughout the history of our planet, they had changed position. Nevertheless, the hypothesis of continental drift was not received positively by the fixist ideas on the genesis of the Earth's relief, and it was strongly criticized. The very idea that parts of the Earth's crust, including the continents, could move on the surface of the planet seemed absurd to them. It contradicted everything that science knew at the time. The scientific community greeted Wegener's theory with hostility, judging him inexperienced, unfamiliar even with the well-known developments of his predecessors, and rejected his hypothesis as attempting to go against the apparently already perfectly functional and dominant paradigm of fixism. The theory convincingly explained a number of events in the history of our planet, but in fact, it was poorly argued. Wegener failed to explain what forces could move entire continents. The proponents of this theory assumed that the continents were the remains of the Earth's oldest crust, which would have arisen as a result of the melting of the bowels of the early Earth's history. These remains were then supposed to be firmly fixed in certain areas of the planet, and the Earth's crust was considered to be capable only of vertical movements, downwards forming the ocean bed, or upwards generating the continents and mountains. Horizontal movements were admitted, but considered very minor. In the same framework, it was thought that the main driver of change was the internal heat of the Earth that was cooling. In addition, they considered that the respectable geological circles on both sides of the Atlantic, and particularly in North America, did not show any coherence. In any case, the idea was considered unsupported by facts and mechanically implausible. For a long time, its role in the sphere of interest of the majority of geologists was therefore negligible. Convinced by his idea, which would provide a new perspective on the geological history of the planet, Wegener did not abandon the work he had begun. His pursuit was facilitated not only by his perseverance, but also by the fact that critics still had not bothered to seriously analyze Wegener's arguments for a new viewpoint. Thus, the author of the hypothesis began a methodical and comprehensive search for data that could bring even more clarity to the problem that interested him. As a result of all his research work, the book, The Origin of Continents and Oceans, was published in 1915, containing not only the new concept itself, but also its solid and versatile justification. After that, it was no longer obvious to ignore the innovative hypothesis. And despite the general unfavorable situation associated with the pressure of the fixist paradigm, serious researchers interested in the continental drift hypothesis began to make themselves known. The most important contribution to the popularization of his theory was made by the British geologist Arthur Holmes. He suggested that powerful convective flows of matter in the depths of the Earth could be the driving force behind the continents. Hot masses would slowly rise from the planet's interior, while cooler rocks would gradually sink deeper. The South African Alexander Logé du Toit, one of the world's greatest field geologists, became Wegener's main disciple at this time. Certainly, accepting the concept of continental drift and drawing on his own experience, Du Toit began to advocate the idea that in the distant past there was not one continuous supercontinent Pangaea, but two supercontinents, Laurasia and Gondwanaland, separated by the ancient ocean Tethys. It was then that the ideas of the Austrian geologist Eduard Suess, such as the ancient ocean Tethys and the ancient continent Gondwana, which included Central and Southern Africa, Madagascar, and the peninsula of India, proved useful. However, the later idea of Gondwana itself also began to refer to South America, Australia, and Antarctica, and thus to this supercontinent. In turn, the term Laurasia referred to a single hypothetical ancient supercontinent of North America and Eurasia. Later, it was realized that mid-ocean ridges extended across the globe, and in 1953, American physicists Maurice Ewing and Bruce Heezen discovered that trenches extended along submarine ridges into deep faults in the Earth's crust. A few years later, another American scientist, Harry Hess, suggested that the mid-ridge system was a zone where new oceanic crust was constantly being born. Hot magma rushes through the faults to the surface, pushing aside sections of the seafloor on either side of the trench. Thus, the main driving force of global plate tectonics had been discovered. Since the mid-1960s, Wegener's hypothesis has finally gained acceptance in the scientific community, becoming the basis of modern geography. The positive change in the interest of the scientific community of the time in Wegener's concept was due to the fact that the author of the hypothesis had managed to gather a whole series of arguments in support of it. The geological evidence for continental drift attracted attention because of the very strange similarity between the Atlantic coasts of South America and Africa, as well as because of the compatibility of the relief folds of one continent with the relief folds of another, as if they were lines from a torn text. The evidence also showed a similarity of geological sections on opposite continents. Meanwhile, a glance at the world map showed that there was an as-yet undiscussed but very interesting possibility in the reconstruction of Pangaea. On a world map, we can see that the Iberian Peninsula, where Spain and Portugal are today, is very consistent in size and shape with the Gulf of Mexico. In addition, we can see that the Florida Peninsula that covers the bay, judging by the map, is surprisingly well coordinated with the Bay of Biscay in Europe. Also, it is edifying to note that deposits of rare heavy metals such as ilmenite, rutile, zircon, and monazite are exploited off the coasts of Florida, in the Gulf of Mexico, and across the Atlantic Ocean, but also off the Iberian Peninsula. In addition, paleontological evidence has explained the phenomenon of Paleozoic and Mesozoic distribution of the same species of plants and animals on opposite continents, apparently completely separated by ocean waters. The new proposal proved to be very important in this regard because the old explanation of the Fixus geologists did not suit the fauna and flora biologists of ancient times. The historical proximity of these particular parts of the planet is also supported by the data of biology and paleontology. For example, the mystery of eels strangely leaving European rivers to swim 6,000 kilometers, or 3,700 miles, to the Sargasso Sea, located just above the Florida Peninsula, to spawn, has long been discussed. It may just be an atavism. 130 million years ago, eels were able to spawn in the Sargasso Sea region when the continents were closer together. Eels settled in Europe, even in the region of the British Isles, which means that in ancient times, the same Bay of Biscay should have been close not to the northern part of the eastern North American continent, but to its southern part. This is also demonstrated by the history of horseshoe crabs, nicknamed horseshoe crabs. Today, these horseshoe crabs can only be caught in the Sargasso Sea and the Gulf of Mexico. However, it is curious that judging from the horseshoe crab distribution zones stand in the Moscow Zoological Museum, horseshoe crab fossils are also found in the British Isles area. This again means that it seems that Northern Europe was located somewhere very close to the Bay of Mexico. The author of the new hypothesis also used paleoclimatic data, which was only a secondary area of interest for the meteorologist Wegener. These data also confirmed his position. They made it possible to determine the position of the continents through their membership in paleoclimatic zones and traces of glaciation. And yet, all these arguments and evidence have not been considered by the geological community as decisive and sufficient. After all, the mechanism for generating such continental drift was not yet clearly established. Subsequently, after the death of Alfred Wegener in 1930 during an expedition to the Greenland ice sheet, the drift hypothesis began to gradually lose its supporters. Opponents also actively worked to discredit it, attacking Wegener with criticism that is now unanswerable, especially because of his unsuccessful explanation of the cause of the drift. As a result, the hypothesis has faded into obscurity to such an extent that mobilism has been taken out of the realm of official science and thus eliminated from the curricula of academic studies. However, as is usually the case, the rejected idea did not disappear completely. It was recalled again in the active search for terrestrial magnetism that took place after World War II, as well as with the intensive sounding of the ocean floor using echolocation. All this evidence then emphasized that in ancient times, the Iberian Peninsula was located in the embrace of the Gulf of Mexico. New arguments necessary to test and develop the hypothesis were retained, and theories in favor of the hypothesis were developed. It turned out that the entire Earth's crust was divided into large separate parts, called plates. It is not the continents themselves that are moving, but the plates to which
aș vrea să ne întâlnim, dar răspundem la mesaj ca să știu când să ieșim. Lunea, sincer, nu aș vrea, că ești moody și nu prea. Mi-aș transforma cea mai nașpa zi în una și mai rea. Marți e o zi proastă de ieșit și nici miercuri nu-i ok. Suntem full, e busy day, parcă și joi sună rău. Ești pe energii prea low, doar să vină weekend-ul și promit că sunt al tău. Vineri eu sunt club, baby, așa că nu. Sâmbătă putem să ne dăm randevous. Vrei să ne întâlnim sâmbătă seara într-o cârciumioară la șosea, unde cântă un pian și o vioară și unde nu ne vede nimeni. Vrei să ne întâlnim sâmbătă seara? Baby, hai, știu cât de mult ai vrea. Te lași greu sau doar faci să pară. Hai că nu ne vede nimeni.
Baby, știu că vrei să mă întâlnești, dar nu te mai zbate atât, că n-aș vrea să obosești. Lunea, sincer, e mai greu, suntem triști și tu și eu. Îți va lua ceva să îți revii din cea mai proastă zi. Arăți-ai o zi cu ghinion și nici miercuri nu-i ok. Suntem full, e busy day, parcă și joi sună rău din un văr de la Bacău. Deci să nu fie într-o zi care se termine în I.
Vineri eu sunt club, baby, așa că nu. Sâmbătă putem să ne dăm randevous.